Welcome back to School of Contribution. Today we are going to solve the following hypothesis testing math. The mean time to locate flight information on internet websites of the major airline companies is generally 2 to 3 minutes. A random sample of 22 Delta Airlines showed average time 2.5 minutes and standard deviation 0.8 minutes. Another random 20 sample of Northwest Airlines showed mean time 2.10 minutes, standard deviation 1.1 minutes. And it is also assumed that the population variance are equal for two airlines. We use 1% significance level to test the hypothesis that mean time to locate flight information for both is same. So now we have to use this data and statistics to answer the following three questions. The first question says that we have to formulate null and alternate hypothesis, then you have to compute the value of test statistics, then you have to use confidence interval approach to test our hypothesis. Before we formulate the null and alternate hypothesis for this math, first we have to determine what type of test is applicable for this math. So far from the math we know that there are two samples over here. One is Delta Airline sample, another is Northwest Airline sample. In the Delta Airline sample we see the sample size is 22, that means n1 equal 22, and sample mean is 2.5, so that means the first sample mean 2.5, first sample standard deviation 0.8, this is the first sample standard deviation. And the Northwest Airline we see the sample size 20, this is the second sample size, and sample mean is 2.1, sample mean 2.1, we just second sample mean 2.1 minutes, second sample standard deviation 1.1 minutes, second sample standard deviation, and for both case we see significance level 1%, so alpha is 1% and also 1%. As we analyze the information, we see that for both case we see first sample size and the second sample size are less than 30. So first sample size, second sample size are less than 30, and we are also given the sample standard deviation, not population standard deviation. So we are given sample standard deviation, and in the math we see it says that it is also assumed that the population variances are equal for two airlines. So if these three conditions are combined, we can say in that case we use t-test for this math. So when the sample size for both sample are less than 30 and population we are given sample standard deviation instead of population standard deviation, and the population variances are equal, variances are assumed to be equal, in that case we use t-test. So this is a t-test method. Once we determine what type of test is this, now we can go on to formulate null and alternative hypothesis as follows. So if we read the last line in the math, we can easily pinpoint our hypothesis over here. It says that use 1% significance level to test the hypothesis that the mean time to locate flight information is same, and same means in mathematical terms equal. So we just put mu1 equal mu2, and for the sake of explanation we refer mu1 as the mean time to locate information for Delta Airlines and mu2 as the mean time to locate information for Northwest Airlines. If we put equal sign in the null hypothesis, we can easily put not equal sign in the alternative hypothesis, and this is the total test, because if we have a not equal sign in the alternative hypothesis, and in that case we use the total test. So this is a total test math. Now we are going to compute the value of test statistics to determine whether we should reject null hypothesis or alternative hypothesis. First we compute the value of test statistics. So to compute this value we have to use the T formula for two population mean test. So from the math we know that our first sample mean is 2.5, our second sample mean is 2.1, and the difference between the two population mean is all time 0, and our first sample size is 22, second sample size 20. Now to compute the combined variance we use the following formula. So this is the formula we use to calculate combined variance, and combined variance given as first sample variance multiplied by n1 minus 1 plus second sample variance n1 to n2 minus 1 divided by n1 plus n2 minus 2. Our first sample standard deviation 0.8, we square it up to convert into variance and multiply with 22 minus 1 because n1 is 22, and then second sample standard deviation 1.1, we square it up to convert into variance, then we multiply this with 20 and 20 minus 1, then we divide by n1 plus n2 minus 2, that is equal 22 plus 20 minus 2, and if we compute this value we get combined variance equal to 0.91, and we put 0.91 over here, 0.91 in both cases. Once we simplify and calculate our value of t, we see that calculated value of t is equal 1.37. so this is the calculated value of t, and the value is equal to 1.37. Now we are going to use this value to decide whether we should reject null hypothesis or fail to reject null hypothesis. So this is our calculated value of t. Now we compare this calculated value of t with the absolute value of calculated t we compare this calculated value of t with the total critical value of t. So we take the absolute value of calculated t, then compare this value with the total critical value of t, because our hypothesis is total, so we compare this with the total critical value. Now to find the total critical value of t, we follow this process, and according to this process we find the total critical value of t. First we divide alpha by 2. Our alpha is 1%. If we divide by 2, we get 0.005. Then we calculate our degrees of freedom. Our degrees of freedom is n1 plus n2 minus 2. Value of n1 is 22, n2 20, and minus 2 means simply we get 40. Now if we combine these two information, that means 40 degrees of freedom with 0.005 significance level, ultimately we get total critical value equal to 2.704 from the t table. We put it over here, then you compare this with absolute value of calculated t with calculated t of 1.37. Now as we see, after the comparison, this value is strictly less than the total critical value of t, and since the calculated value is less than the critical value of t, we fail to reject null hypothesis. Fail to reject null hypothesis means we fail to reject null. In other sense, we are rejecting alternative hypothesis. So our decision is we fail to reject null hypothesis because our calculated value of t is less than the total critical value of t. Now we are going to use confidence interval method to test this hypothesis once again. So this is the confidence interval method of testing, and the formula for confidence interval for t-test is this. As we see over here, this is the mu1 minus mu2 is the difference between two population mean. This is the difference between the two sample mean. This is a combined variance, combined standard deviation. Now we have to log one critical information over here, that is t alpha by 2. Okay, so we have to log this information very carefully. This is the t alpha by 2, and this t alpha by 2 means total critical value of t. So in constructing confidence interval, we have to always use total critical value of t. Whether hypothesis is one tail or total, it doesn't matter. We always use total critical value of t. Now from the math we know that our first sample mean is 2.5, second sample mean 2.1, our combined variance is 0.91, first sample size is 22, second sample size 20. Now what is the total critical value of t? To find the total critical value of t, we have to follow some process. The process is as follows. So to find this critical value of t, first we divide alpha by 2. From the math, our alpha is 1%, we know that. If we divide by 2, we get 0.005 significance level, and we have to calculate degrees of freedom. Our degrees of freedom is n1 plus n2 minus 2. Value of n1 is 22, n2 is 20, minus 2 means 40. Now if we combine these two information in the t table, then ultimately we get the total critical value equal to 2.704. So now we substitute 2.704 total critical value of t in the formula. So far this is our simplified calculation, and this is the value of the combined standard deviation. This is 0.29, and we put 2.70 over here, and the difference between 2.5 and 2.1 is simply 0.40. Now once we simplify, if we multiply these two quantity, we get 0.78, and then at one time we plus this quantity with 0.4, and then another time we minus this quantity with 0.4. If we plus, we get one interval value that is referred by mu1 minus mu2 single prime, and that is equal to 1.18. If we minus this quantity, that means 0.78 from 0.40, we get another interval value that is equal to mu1 minus mu2 double prime, and that is equal to minus 0.38. So these are our two interval values. Now we can use these two interval values to make our conclusion whether we should reject null hypothesis or fail to reject null hypothesis. So as we see, these are our two interval values. These are first interval value, these are second interval values. As we see, our one interval value is positive, another interval is negative. So by the rule, if we know that in case of total test, two population mean test, if in case of two population mean test for confidence interval method, if one value is less than 0, other value is greater than 0, in that case we fail to reject null hypothesis, because we have 0 in between, because this is the hypothesis population mean difference. This is all time 0, and as we see, one value is positive, and another value is negative. So another value is negative. So if one value is negative, another value is positive, in that case we fail to reject null hypothesis according to confidence interval testing rules for two population mean test. So we fail to reject null hypothesis. Now we can show this result graphically as follows. So this is our hypothesis population mean, and as you see, this is one of the interval values, and another interval value is minus 0.38, This is one interval value, that is 1.18, and in this interval, as we see, this is our 99% confidence interval, and in this interval we see that our hypothesis population mean 0 exists at the center. So since our hypothesis population mean is contained in this interval, we say we fail to reject null hypothesis. So far we have come to the conclusion that we fail to reject null hypothesis using the confidence interval method for t-test for two population mean test, and also we fail to reject null hypothesis using the test statistics method of testing. And we have also formulated our null and alternative hypothesis. Our null hypothesis, as we see over here, our null hypothesis is mu1 equal to mu2, and alternative hypothesis is mu1 not equal to mu2. And according to our result, we see we fail to reject null hypothesis. In other sense, we reject null alternative hypothesis. And this is the complete solution of this math.